Now let us see the properties of this first simplest form here, whatever we have derived just now. Its equation is y square equals to 4ax. Let us start with this first point, y square equal to 4ax. Regarding its location, this is a parabola defined with vertex, origin, principal axis taken as x-axis, and focus is lying somewhere on positive x-axis. If A positive, we can take the parabola in this location. In case if A is negative, we can take the same parabola on the other side. Whether it is positive or negative, always the focus position will be at a comma 0. A may be positive or A may be negative. This is the location of the parabola in its first simplest form. If we analyze the properties of this particular curve, its vertex is origin, its focus is a comma 0 irrespective of its position, whether it is right side or left side. Fourth one, its principal axis is x-axis, that is y equal to 0. Now its directrix, as we have discussed already in the equation itself, x equals to minus a will be its directrix. Now coming to its latus rectum equation. Latus rectum equation because it is a vertical line whose equation is x equal to k form, that k is equals to a. So latus rectum equation is x equals to a. Solving this latus rectum equation with the parabola, substituting x equal to a in the parabola. If we substitute a here, y square is 4a square, then y will be plus or minus 2a. One is in first or second, other one is in third, and third or fourth will come. These two are taken as ends of latus rectum, a plus or minus 2a. Now distance between these two, if we calculate, we are getting length of latus rectum 2a minus 2a. Distance between these two vertical points is 4a will come. To avoid ambiguity of negative case, we use mod 4a, because a may be negative if we are taking on the other side of this origin. Now if we are choosing a point P randomly somewhere on the curve, SP is called its focal distance. SP equals to, we know that it is equal to PM. SP is equals to PM. This PM is nothing but distance from P to the directrix. Distance from P to the directrix, if we calculate this one, this length is A, this length is x1, it becomes x1 plus A. If it is, suppose if A is negative, we can make it positive also. Okay, now here this is taken as focal distance of a point from focus to the point on the curve. SP is calculated by using this. Here this is the 9th point of this. Now apart from all these, coming to its parametric form, any point on the parabola in its first simplest form can be taken with a single parameter t, at square 2at, which will satisfy the curve equation always in its first simplest form. Just we are converting two variables abscissa ordinate into a single parameter t, at square 2at is taken as its parametric form. Now entire other forms, second simplest form or shifting cases or general parabola, whatever we take, we are just depending on these first 10 points we have derived. By using this first 10 points of the first simplest form, we can analyze the properties of other cases also by using simple transformation of axis. Let us see how to get properties of remaining forms with the help of this first 10 points now. If we analyze the second simplest form, now suppose if we want the second simplest form, in this second simplest form, suppose this is the first form. Now just we are rotating this one through 90 degrees clockwise or anti-clockwise depending on the case. We get the second simplest form in this expanding vertically either upward or downward. If we observe closely this one, now these two curves are observed clearly as images to each other with respect to the line y equals to x. These are images to each other with respect to the line y equal to x. That is why we get all these properties in very comfortable way by taking the image with respect to this line y equal to x. Here, if we want any property related to the equation, any equation f of x comma y equals to 0, equation can be modified as now y comma x. Simply interchanging x and y, we are getting any equation to this second simplest form. That is, for example, y square equal to 4ax. Now it will be written as x square equals to 4ay. This is taken as second standard form, second simplest form. Just we are interchanging x and y. For example, principal axis y equal to 0 is taken for the first form. Now replacing y with x, you are getting x equal to 0 as principal axis to that. Directrix is here x equal to minus a, and there it will become y equals to minus a. Lattice rectum equation x equal to a will be written as y equals to a to the second simplest form. Like this, all the equations of the second form can be obtained by interchanging x and y values in this. In similar way, if you want the coordinates of any point, some x comma y point is taken, simply it is replaced with y comma x. Interchange abscissa and ordinate, we are getting the properties to the second simplest form. For example, vertex, interchanging 0 0 makes no difference, vertex is remaining same. Focus S will become 0 comma a to the second simplest form. Here plus or minus 2a comma 0 are ends of lattice rectum. While rotating, the lengths will never be changed. That is why length of lattice rectum will remain same, modulus 4a. Focal distance SP will be taken as y1 plus a, and parametric form obviously will be taken by reversing abscissa and ordinate, that is at square comma 2at. So like this, with the help of first 10 points of the first simplest form, by using transformation of axis, that is rotation of axis concept, we can get in a very simple way properties to what? The second simplest form. Not only this second simplest form and first simplest form, sometimes we may have to shift the parabola from one point to other point without disturbing the axis. In that case, we take two more forms which are called shifting cases. If we analyze the first shifting case now, if we take the first shifting case, axes are here somewhere. We imagine a point alpha comma beta. There the parabola is shifted as it is without changing its direction. This is taken as the first shifting case. To get any property of this first shifting case, Again, just we depend on these first 10 points. To get all the properties of this one, if you want any equation, simply f of xy equals to 0 written as f of x minus alpha y minus beta. Replace x and y with x minus alpha y minus beta. You are getting all the properties related to equations for first shifting case. This is taken as first shifting case. Here y is replaced with y minus beta. Y minus beta whole square equals to 4a into x minus alpha. Standard form will come. For example, you want principal axis. Actual principal axis is y equal to 0. Now written as y minus beta equals to 0. If you want the lattice rectum equation, x minus alpha equals to plus a. Directrix equation, x minus alpha equals to minus a. Like this, all the equation related properties we can write simply by replacing x and y with x minus alpha and y minus beta. And in similar way, in case of coordinates, any point x comma y written as x plus alpha y plus beta. Simply abscissa and ordinate are added by alpha and beta respectively. This is taken as the transformation, standard transformation we are using for getting properties of first shifting case. If you recollect once again, if you want the equation related points, x and y in equations replace with x minus alpha and y minus beta, whereas if you want the properties related to coordinates of a point, replace, just add alpha and beta respectively to abscissa and ordinate. This is the way of getting entire properties of first shifting case, and one can guess very comfortably how to get transformations in second shifting case. In case of second shifting case, we rotate the parabola like in second form. After rotation, we are shifting as it is to the point alpha comma beta vertex. That's why in second shifting case, we apply simultaneously these transformations and second form transformations. That means x and y will be interchanged, points will be reversed abscissa ordinate, and x and y replaced with x minus alpha y minus beta. Interchanging and replacing both are applied simultaneously in one. That is the strategy we are following for getting second shifting case properties. For example, if you analyze some general points, so if we tabulate all these transformations all together in one, first simplest form, second simplest form, first shifting case, and finally second shifting case. If you take always we focus on properties of first simplest form. First 10 points we have derived. Based on this, we always try to recollect the points to the remaining cases. Those key transformations, here I am listing out once again all together here. Any equation f of xy equal to 0 if you are taking for first simplest form, this will be written as f of y comma x equals to 0 for second simplest form. Coming to the first shifting case, if the vertex is shifted to alpha beta new point, now we replace x and y with x minus alpha, y minus beta respectively. Now, in case of second shifting case, we apply both simultaneously here, reverse and replace. Then it becomes f of y minus beta comma x minus alpha equals to 0. This is the first transformational technique we use for writing equations of any form. And whereas coming to the points, if a point x comma y is taken in first simplest form, it becomes y comma x in second simplest form, and it will become alpha plus x, beta plus y in first shifting case. Now, the last point, when you are using second shifting case, any formula for point related, here we interchange first. X and y will be interchanged, then added by alpha beta respectively. It should be added by alpha and this should be added by beta. Now, for example, how to use this effectively? Just by taking one simple example we can say here. For example, ends of lattice rectum if we are analyzing. As we know already, I told you to focus only on first simplest form, a plus or minus 2a. Now, if you want the ends of lattice rectum to this last form, second shifting case, I told you to use interchanging first, then it becomes plus or minus 2a and a, then these are added by alpha beta. So, alpha plus or minus 2a and beta plus a, these are ends of lattice rectum for second shifting case. Here, suppose the focus S is a comma 0, then focus to the first shifting case if you want. In case of first shifting case, interchanging is not necessary. First shifting case, what is required only? Just it is added by alpha and beta. So, focus for this will become alpha plus a comma beta plus 0. Like this, by using simple transformational techniques, we can get all the properties for second simplest form, first shifting case as well as the second shifting case. Always just we focus on first simplest form 10 points. Half of the chapter we can comfortably finish with the help of this first simple 10 points. After that, we enter into individual properties like tangents properties, normal properties, focal properties separately for your convenience. So, definition related, curve nature, locus related, all can be traced out very comfortably with the first simplest form 10 points always. And by using this only we are getting other cases by using simple transformation techniques. Now here we also should take care of the other cases. Here just we have concentrated on simplest forms as well as shifting cases. In case if the curve is, if the parabola is not belonging to any one of these, if it is an inclined one, if it is neither vertical nor horizontally expanding one, then it is taken into general form, that is whose equation will be written as second degree non-homogeneous. For analyzing that one, in what way this is helping us to understand this one, essentially here we have to introduce the fifth form also. That fifth form is taken as the distance form of a parabola. Here let us see how this distance form helps us in analyzing the fifth form. Now, let us take parabola in its first simplest form, y square equals to 4ax, on which let us imagine a general point p x1 comma y1. Because it is a point lying on the curve, it will satisfy this equation. So you are getting y1 square equals to 4a x1. But we know that y1 is ordinate, x1 is the abscissa. This Pm is taken as its abscissa. Pn, this is taken as its ordinate. Now, we can also write this equation as Pn square, y1 square, Pn square equals to 4a into x1 is taken as in the diagram Pm. Here, this Pn is nothing but perpendicular distance from the point to the principal axis. So we can write it as perpendicular distance on the principal axis whole square equals to the length of lattice rectum 4a into perpendicular distance on Pm is nothing but perpendicular distance on y-axis. But here y-axis is nothing but tangent at vertex to the curve. That's why we can write it as perpendicular distance on the principal axis whole square equals to 4a, the length of lattice rectum, into perpendicular distance on tangent at vertex. Just we can consider this as the important fifth standard form. This is also taken as the distance form. Here, when we are shifting the origin from one point to other point, parabola shifted or origin shifted or rotated or rotation followed by translation, whatever we do, this fundamental property based on distances will never be changed. While rotation and this shifting, equations may be changing, points may be changing, but the conditions based on distances related will never be changed. By using that fundamental fact, we are writing the distance form of the parabola as so. Here, any parabola will satisfy the condition perpendicular distance on principal axis whole square equals to length of lattice rectum into perpendicular distance on tangent at vertex. So this is considered as fifth standard form. This is also called the distance form. By using this particular distance form, we analyze especially the properties of second degree non-homogeneous curves, parabolic curve. Here, how to get the properties by using this, let us analyze now by taking one simple example. Suppose a parabola equation is given like this: x minus y plus 3 whole square equals to 8 root 2 into x plus y minus 2. If we recollect the distance form, perpendicular distance on principal axis whole square equals to length of lattice rectum into perpendicular distance on tangent at vertex. The first fact we have to analyze here is these two lines given in the equation are perpendicular or not, we check. Obviously x plus y minus 2 and x minus y plus 3 equal to 0 are perpendicular to each other. So we can take this as principal axis and we can take this as tangent at vertex. But to write it into standard form, still we require one more modification, that is these equation to be converted into distance form. We know that perpendicular distance from the given point to a given line is ax1 plus by1 plus c by root of a square plus b square. That root of a square plus b square is missing here, making sufficient multiplication both sides. Here x minus y plus 3 by root of a square plus b square is root 2 whole square if we write. Here we are dividing with what? Root 2 square is 2. The same 2 is divided right side also. You are getting 8 root 2 into x plus y minus 2 by 1 root 2 here, another root 2 here. So that 2 is multiplied both the sides. Now this root 2 cancel. Now this is perfectly in distance form. Perpendicular distance on principal axis whole square equals to 4a into perpendicular distance on tangent at vertex. Completely we are getting the shifting case distance form of a parabola here. Once we get the distance form, then we can use some assumptions. Before that we should never use assumptions. Now we can write this entire parabola into simple form y square equals to 4ax. For that we just take this as capital Y and we take it as capital X. We use the assumptions capital Y taken as x minus y plus 3 by root 2 and capital X is x plus y minus 2 by root 2 and 4a is obviously 8. After getting the standard distance form, if we use these assumptions, we can blindly apply first simplest form properties all to get any result to this. For example, if we want the focus of this, the focus S is a comma 0 we know, because we are assuming y square equal to 4ax. First form focus is a comma 0, but the difference is these are capital X and capital Y coordinates. That means capital X, this is representing capital X equals to a and capital Y equals to 0. We require the original coordinates in small x and small y. For that, instead of writing a comma 0, we solve capital X equal to a and capital Y equal to 0. On solving, we are getting the focus. That is capital X, this is capital X, x plus y minus 2 by root 2 equals to a is 2. So x plus y minus 2 root 2 equals to 0 and capital Y equal to 0 is x minus y plus 3 equals to 0 into root 2 0. Solving these two equations, you are getting the focus. So this is the way of getting focus, not only focus, any other thing required. For example, you require lattice rectum equation. Lattice rectum equation, we know that x equal to a. Now this is written as capital X equals to a. This is the way of writing any property for this second degree non-homogeneous general parabola here. But a very important other fact we have to remember while doing this one is, once the given equation is almost in simplified form given, it is easy to get all these properties. But sometimes the curve may not be given in simplified form. General second degree non-homogeneous equation in x and y may be given. In that case, we have to convert the equation into this distance form. Only distance form will help us in tracing out its location, properties, everything. That is why, for that also just one simple example is enough to make you comfortable to understand how we are getting this standard form. For this, let us take one general parabola. Second degree non-homogeneous we are taking now. Let us analyze one curve x square minus 4xy plus 4y square. As I told you already, in a parabola, second degree non-homogeneous, if it is representing a parabola, first three term, that is homogeneous part, will give you complete perfect square. So here it is a perfect square here, plus some 2x minus 4y plus 3 equals to 0. Because h square equals to AB, definitely delta if not equal to 0, determinant not equal to 0, h square equal to AB, obviously it represents parabola. Now how to get its vertex, how to get its focus, how to get its lattice rectum equation, etc. all, first we have to convert this into the distance form. For getting the distance form, we have to get principal axis, tangent at vertex and lattice rectum, etc. To get them comfortably, let us see the method involved in this. We know that from this equation, x minus 2y whole square equals to minus 2x plus 4y plus 3. Take this as number 1. Let us take this as equation number 1. Now, with the help of this, we have to get the standard form. We know that this equation will be written in what form? Perpendicular distance on principal axis whole square. So, whole square term definitely contains principal axis. That is why principal axis definitely contains this term. So, let us analyze, let us take this curve as x minus 2y plus some constant L whole square equals to some length of lattice rectum, some lambda, into perpendicular distance on tangent at vertex. The tangent at vertex is obviously perpendicular to this. So let us take this equation as 2x plus y plus k. This is just we have taken perfect square equal to these terms other side. After that, directly I am assuming the required parabola to be taken in this form. Now our task is finding L, lambda and k, so that this will represent this equation. For that we are taking the help of this step 1. So if we expand this one, x minus 2y whole square plus L square plus 2L into x minus 2y equals to lambda into 2x plus y plus k. Replacing this perfect square with this one, minus 2x plus 4y plus 3 plus L square plus 2L into x minus 2y equals to lambda into 2x plus y plus k. Now, comparing the corresponding coefficients on either side, on comparing coefficients, corresponding coefficients, if we compare the x coefficients, right side 2 lambda equals to left side minus 2 here plus 2L. Entire 2 cancel, you are getting L minus lambda equals to 1. L minus lambda equals to 1. Take this as equation number 2. Comparing y coefficients, 4 minus 2L into 2 minus 4L, 4y minus 4Ly equals to lambda y. Comparing coefficients, we are getting this. So 4L plus lambda equals to 4. Solving these two, clearly we are getting L equals to 5L is 5, L equals to 1, lambda equals to how much you are getting? 0. If lambda is getting 0, this is definitely not representing a parabola. One simple logic here, if it is getting 0, just definitely we have taken some pair of straight lines, because we did not check the determinant whether 0 or not. Without starting, just we have gone through the simplifications. it indicates clearly that if lambda is getting 0, this part is 0, so this equation can be written this form. Obviously, it represents a pair of straight lines. That's why, in general, if it is a complete hyperbola, then definitely here we get some lambda number. Substituting lambda and L in the third condition, then you are getting k value also. Then finally we get parabola in this form, if it is representing a parabola. Of course, we have taken numericals randomly, that's why in this case coincidentally we are getting a pair of straight lines, but the procedure will not be changed. If it is representing a parabola, first perfect square equal to, we write a linear equation in x and y. Using this, we assume this equation as this x minus 2y plus some L whole square equal to some lambda into its perpendicular line form, 2x plus y plus some k. On comparing the corresponding coefficients both the sides, we get lambda, L and k values. Then substituting back, we are getting parabola in its general form. If we both sides divide with root of a square plus b square, and we can convert it into distance form, and we use the previous technique to get all the properties of this parabola. This is the mechanism we follow for getting properties of such a lengthy second degree non-homogeneous parabola, for getting properties very comfortable way. This is the way of getting the properties for all the cases: first simplest form, second simplest form, first shifting case, second shifting case, as well as the general distance form of the parabola. Any type of parabola given anywhere, any location, this is the simplest mechanism we use for getting this tracing of the curve properties.